the access network, and in about 2018 it will be the same as with routers and switches, and transport is even lower. So I've put this graph up here because this is a good introduction, I think, to a way of looking at this factor of 1,000 and how it fits into the network. And just to explain a little bit more detail, the objective of Green Touch is to, by 2020, make the energy efficiency of the network 1,000 times better than it is when Green Touch was formed, which was in 2010. In fact, Green Touch hopes to achieve all this by 2015, but the idea is by 2015 the research will be done, which will enable us to, by 2020, get a factor of 1,000 improvement over the time, over what the efficiency was when Green Touch was formed in 2010. So let me show this slide, which I think will put this into context. And this is a little complicated, so I'll go through this a little slowly. First of all, the top part of this curve shows pretty much what I showed before, the energy per bit for the access network, routers and switches, and the transport network based on current trends, sloping down because of we're expecting improvements, business as usual improvements in all those areas. And this, by the way, is the network energy per bit. So I've worked out the energy per bit for each individual device and then scaled it up to a global network. So it's how much energy you would actually expend if a bit of data is transferred from one point on Earth to another. So in 2010, you can see that the total is about 10 to the minus 5, or 10 microjoules. So today, if I send a bit of data from one point on Earth to another point on Earth via the network, it will consume about 10 microjoules. The bottom curves represent our estimates of sort of theoretical lower bounds, and I put inverted commas theoretical lower bounds because some of these are hard to grab onto. Some are easy, like Shannon's law, but others, when you talk about switching and networking, are a bit harder to grab onto. But basically the theoretical lower bounds are well below current practice, and I've shown there's a slight difference between switches and transport. In fact, it's about, even in 2020, it's about 4 orders of magnitude lower than current trends would take us. So what are we trying to do in Green Touch? In Green Touch, we're trying to take the current trends in 2010, when Green Touch was established, and by 2020 reduce the energy by a factor of 1,000 to the value on the right. And you can see that we're getting somewhere roughly halfway between current trends and the theoretical bounds. So, of course, we will never in a real engineering system ever get to the theoretical bounds because we always have overheads on the network, but this is a pretty realistic goal. And you can see, in fact, what Green Touch is actually doing is getting something approaching 2 orders of magnitude beyond what we see as being the current trends in 2020. All right, how is Green Touch making a difference? Now, don't get me wrong, I'm not one of these people who gets excited by organisational charts, but this gives you an idea of what's going on in Green Touch. Don't worry about all the board and all those people, but down the bottom is where everything really happens, and we have a number of working groups that focus on different aspects of Green Touch. There's a fixed access working group, a mobile communications working group, and G has talked about some of the work they've been doing already, core transmission, core switching and routing, and I should, by the way, point out that there is also an equally important working group and network committee, the Services, Applications and Trends Committee, because working on the technologies down on these bottom working groups is very important, but as I said, as I pointed out earlier, if we're modelling the energy consumption in the network, we need to think about the services that are being used, because different services will use different parts of the network, and in fact different networks will be designed for different services. So we have a Services, Applications and Trends Committee that works with the working groups to develop that modelling work. So you're going to hear quite a lot about some of this in this conference. G has already talked about some of the mobile communications. There'll be other speakers from Bell Labs in mobile communications and in fixed access networks. And today and tomorrow, Peter Windsor and Jafar are going to talk tomorrow in core transmission, and Terry Klein, who's down here, and David Nielsen via video is going to talk about the core switching and routing activities tomorrow. So in this conference you're going to get a very good broad view, I think, of things that are going on in Green Touch. But let me just give you a couple of examples. Here's one that's close to my heart. I'm particularly excited by passive optical networks, and it's interesting to think about what's going to happen in the future of passive optical networks. Today we have GPON and EPON, which are standardised in 2002, which is widely deployed, and it provides this kind of energy efficiency that I've talked about already. But in the not too distant future, it's likely that we'll move to more advanced technologies like XGPON or 100G EPON. These have already been standardised, and in fact it was this next generation of GPON that the important bit interleaved demonstration that G talked about was announced last week. So it was in fact in one of the more advanced aspects of PON technology. But things are not going to stop, and in the future there will be a need for even higher speed access networks. And so in Green Touch, as well as working on current technologies, we're looking about possibilities for future technologies where the core part of the PON works at 40 gigabits per second. Here is a slightly more detailed slide describing the bit interleave PON that Peter Vett is going to talk about later, that was announced last week. The top slide is the bit interleave PON, and the bottom one is the standard one. And the key difference is that in standard PON, data is fed from the line card in the telephone exchange to the user in packet form, and each packet is sent to all users, and the users have to differentiate between the packets that arrive and pick out which ones are for them. In the bit interleave PON at the top, the bits are interleaved in a way which is not like packets, but sends those bits directly to the ONUs in the user modem and uses much less energy. So this BIPON DS little box there in the top part of the slide uses much less energy than in the conventional PON, and you'll hear more about this from Peter. As I said, we're looking at future 40 gigabit per second access options, and thinking very carefully about how these future non-standardised so far options could provide lower energy efficiency. And here's four alternatives. An active optical splitter. You can't go to 40 gigabits, you can't just take an existing PON and go to 40 gigabits because there are power and dispersion issues, but an active optical splitter is one option there. The second one on the right, on the top, is the coarse wavelength division multiplexed system combined with TDM that has a combination of two technologies that are well known, but no one's really looked carefully at how much energy it uses. On the bottom left is dense WDM. It's basically applying a kind of technology that's used in the core network into the access network. And the one on the bottom right is a left field technology that in fact uses in the field an active switch, an electronic switch to forward the data to the user. And I'm not going to go into great detail here, but the interesting thing is you can track out into the future, taking into account Moore's law improvements, the energy efficiency of these various technologies. And surprise to us was that the best of all in terms of energy efficiency is the bottom one. Out in 2020 we're predicting 1.8 nanojoules per bit for the electronic switch. So and we have a very good model of all of these, but I guess the important conclusion here is that by doing research that doesn't just follow the conventional approaches but thinks about left field approaches, who would have thought an electronic switch in the middle of a passive optical network produces the best energy efficiency? And this electronic switch, by the way, uses a very small amount of power. So from a point of view of power consumption and supplying that power could be quite efficient. In fact, solar cells would be a solution for this one. I'm not going to say much about core networks here because my time is limited and I think I'm getting over time already. So I'll skip through this slide, which is the core networks. You're going to hear more about Green Touch work in this from speakers later in the conference. One particular project that I think that David Nielsen will be talking about is a core switching and routing project, which is about a silicon photonic interconnect and a router on a single chip. We have a tradition in Green Touch of naming our projects after animals, and this one's called Scorpion. The projects, by the way, from Australia, from my group in Australia, all have Australian animal names like crocodile and emu. So this one is Scorpion and looking at silicon photonic interconnects. There is also a project looking at optimal end-to-end resource allocation, and I just contradicted myself. I think this is the only one that doesn't have an animal name. This is Opera. And what this project does is take into account resource allocation. So I guess what I'm trying to point out here is that our projects are not just technology oriented. We also have projects that think about resource allocation, about how data is managed in the network. And you can see from the bottom there are quite a number of contributing members. So why does your organisation need to join Green Touch? Or if your organisation is already a member of Green Touch, why do you need to be actively involved? Well, first of all, there's lots of great collaboration amongst diverse groups. And from my point of view, as a university professor, it's the opportunities for collaboration that for me are the key driving motivation for being part of Green Touch. We have a lot of great interactions going. We've met a lot of really interesting people from different groups around the world, and we're working with them. And our horizons have broadened through working with other groups. And this is an example in fixed access network showing how, and I won't go through the whole thing, there are different sub-projects all focusing on getting a fixed access network with lower energy consumption. Bell Labs, you can see, Broadcom, University of Cambridge, IB, BT, and the list goes on. These interactions are tremendous. And there are exciting projects, and this is an example of some of the great projects going on. And there are exciting new projects coming on all the time. So for me, again, being involved in exciting projects like this really helps the excitement level to go up. And the people in my lab are really excited by this also. And Green Touch is an opportunity for you to participate in a reinvention of the internet. So in conclusion, Green Touch's goal is to reduce the energy per bit by a factor of 1,000 by 2020. And this requires about 100 times more improvement than we can just get by sitting back and letting Moore's Law do the work for us. We've got a multi-pronged approach in Green Touch, which I think is highly appropriate: fixed access networks, wireless, switching and routing, core networks, and with a strong focus on services and applications. And we've made great strides and more to come. So my message is Green Touch needs you. Thank you.
We'll just take maybe a couple of questions because it's not time.
Describe some very interesting trends for various technologies, and given that access seems to trump others in terms of energy consumption, one possible approach could be, especially as end devices are becoming smarter, one possible approach could be that devices and networks sort of work cooperatively. End user devices and networks work cooperatively to reduce the overall energy consumption, especially say mobile devices, right? And you could conceive various ways in which that could be done. So, but my question is from sort of a more of a trends perspective. Do we have an insight that, I mean, if a few billion mobile devices are doing a little bit more for the network to keep the energy efficiency of the network good, is that a good thing? I mean, if all of these devices do something more from an overall energy consumption perspective, is that a good thing?
I think I understand your question. I couldn't quite hear it all, but certainly we need to make sure that the device, each individual device responds to the network environment it's in, depending on the traffic. So I think examples of the kind of things that can be done are sleep mode in various items of equipment. So whether it's a modem in the home or whether it's a router in the core of the network, if If parts of the router or if the whole modem can go to sleep when there's no data and use very small amount of energy, then